In this video, we are going to go over 5 examples of how to divide powers. Let's jump right into this. Let's quickly review the general rule that we've discovered in a previous video of why it works, and now we're going to go over how it works. So we've got any power divided by any power, as long as they have the same bases and the base is not equal to 0, then what we do is we keep those bases and we subtract the exponent of the numerator minus the exponent of the denominator. And again, if you have trouble understanding why that is, please check out that earlier video. Now we've got 4 to the 7th divided by 4 to the 5th power. We're going to keep the base, which is 4, and subtract the exponent in the numerator minus the exponent in the denominator, which would be 7 minus 5. And so that's going to be equal to 4 to the 2nd power. Now, a lot of teachers, including myself, will want you to simplify that further because you can do 4 squared in your head. That's 4 times 4, which is 16. So that is our final answer. Now, on to number 2. We have x to the 12th divided by x to the 5th. We keep the bases the same, and we subtract the exponent of the numerator minus the exponent in the denominator, and that's going to give us x to the 7th power. And that is as simple as it gets right there, folks, just following that rule, and it's simplified. All right, now we're going to go up on a little wild goose chase up to number 3 here, then to number 4, then to number 5. It's like a where's the problem kind of scavenger hunt. Okay, anyway, let's dive into this. I put this problem on here because a lot of students will automatically subtract 8 minus 6. They see the division and they get into this groove of saying, okay, now I've got division, so I subtract. Remember that the rule says that when we have the same bases, we're subtracting exponents to figure out how many of those bases we have remaining. 8 and 6 are bases. Their exponents are each 1 technically, so you were dividing them like normal, doing negative 8 over 6, reducing that fraction. So we divide the numerator and denominator by the GCF of 2, and that would give me negative 4 over positive 3. So I've got negative 4 thirds. That's the first part. That's just from the 8 and the 6. A lot of people will simplify it like this. They'll put a 4 up here, and they'll put a 3 down there. Now, 8 to the 7th over 8 to the 3rd. I take that and I kind of do it off separately. So I've got my negative 8 over 6, and I clean up this mess separately, and I say that's the same as subtracting the exponents of the numerator minus the denominator. 7 minus 3 is 8 to the 4th. So I end up with my answer with 8 to the 4th in the numerator. You could also write that as negative 4 thirds, 8 to the 4th. Kind of up to you how you write it. The whole point here, folks, is when all of a sudden you have more than one term or more than one piece to a term in a numerator or denominator, separate out your thoughts into individual pieces so that no matter how big of a mess you have going on, you can do the workout in small, simple parts. Same thing here. I'm looking at this problem and I'm really doing x to the 5th minus, and now let's think about this. That's x to the 1st, so that's x to the 1. So in my head, I was actually off doing x to the 5th over x to the 1. That's the work that I'm doing separately in my brain. And that gives me x to the 5th, well, x to the 5 minus 1, which is x to the 4th. So we'll write this down here. So I'm left with x to the 4th from 5 minus 1. Now I'm going to go off and separate y to the 17th over y to the 8th, just kind of off on its own. And that's y to the 17th over y to the 8th, all in my head. And that again is y to the 17 minus 8, subtracting the numerator exponent minus the denominator exponent, which is y to the 9th. And technically we have nothing left in the denominator except for 1, so we just have x to the 4th, y to the 9th. Awesome stuff. Split up everything into simpler messes. This is a giant mess, so how are we going to take care of this one? Well, very simply, let's do 18 over 27 first. So in my brain, I'm handling this, and I know it's kind of weird that it's kind of off on its own, but just handle 18 over 27. That divides down by 9 in the numerator and 9 in the denominator, leaving me with 2 thirds. So 2 thirds is already on its own. So let's kind of put all our answer pieces here. So I've got 2 thirds, and I'm just going to kind of expand that out, and we'll see what we end up with. The next bit of work I'm going to do is a cubed over a squared. So I'm doing that off separately in my head. We've got the same bases, so we're going to subtract the exponent of the numerator minus the exponent of the denominator and keep the base. That leaves me with a to the 1, or a. And then I've got b to the 6th over b to the 4th. So b to the 6th over b to the 4th. which again, we're going to keep the base because it's the same and subtract the numerator exponent minus the denominator's exponent, and that gives me b squared. So b squared now goes back into my main project here. And that's your final answer, 2ab squared over 3, or 2/3 times a times b squared. They're all the same. The moral of the story here, peeps, follow your rule, keep the base the same, subtract numerator exponent minus denominator exponent, and no matter how messy that problem is, you can handle it. Split it into separate thoughts. I know that when you look at this board at the end, it looks very messy. But if you need to, rewind the video so that you can see how I separated out my thoughts into individual pieces, making the problem basically smaller bites that I could handle, and then putting it all together in one finishing statement. Go rock some practice.